Okay. Welcome. This is going to actually be the final projects video. Here, let me turn on my camera. I had it turned off last night because I was playing Cyberpunk on Twitch, or all the way to this morning actually. Um, so like I had said previously, I'm pretty much already done with all the coding, and well, I'm done with all the coding for this project. Let me rephrase that, because there's a number of things in this project that I want to do and get better at, and that's the waypoints, the pathfinding, and everything else. I love the fact that I was actually forced to go well outside of my comfort zone and do the whole procedural generation, because that was a huge step for me. And what that did for me was it made me get outside of my comfort zone, and in making me get outside of my comfort zone, it actually helped me grow as a developer. So yeah, before I really get into anything else, just like to say thank you. It was a very deep and inspirational learning experience for me, because it helped me try and fail at things enough times that I now feel a lot more confident when it comes to game programming, not just programming in general. Alright, so main menu exists and buttons for options, start game and quit game are functional. Alright, so in order to show this, I actually have to I'll just show that the start game works, and then I'll build it and show that the exit game works too. So there's the start game, currently set to 2 players, because that's what it saved for player pref, and there's the 2 players moving independently of each other. Here, I'll tilt down the camera real quick so that you can see what they were mapped to. So there's player 2's controls, and here's player 1's controls. So you can actually see the different control sets. So they're mapped to different controls, and I'll just go ahead and stop the game right there. In order to do the file, save, file, build and run. Oh. Huh. Oh. Yeah, whatever. It's not letting it build because I'm using a custom editor instead of using a direct implementation for the field of view. I would actually have to exclude that from the builder, but it's not important. Here's the option. Well, let's keep going down the list. Option menu exists, and select option menu exists and selections for the sound effects volume, the music volume, and 1/2 players, and map of the day slap random map are available. Okay, so here we are. We have master volume, we have music volume, and you can hear that even between the instances of the game running, since it's saving to player prefs, it'll automatically default to previous values that were set. And these were actually set when I was doing the video the other day. So we have map of the day, which chooses where the level seed starts off of the basis of what the current map of the day is, what the current day is. So today is Sunday, so it would use the basis of 0 for the map seed sent, or some other assigned number to the day of the week if you want to cross-correlate them. But for me, it would just use 0 because that's the enumeration for Sunday. And you have the level seed down here, which changes where the level seed starts if you don't have this selected, and it runs from 0 to 24. Yeah, that's pretty much it for the master volume, and for the music volume, the sound effects volume, and the player count. So that's the options there. Map size adjustable by designers, and at least 3 source tiles exist. Okay, so I'm going to return to main, and I'm going to shut that down so that we can go to the level 1. Now for the map generator, it's showing up in here, but you have the power-up room, the room variant, and the spawning room. And what that does is it just allows, those are the 3 prefabs that I use for the room generation. And then here are the slides in the inspector that determine the number of rooms that you're doing for the variable size. So right now I have it set to 6, but I can actually turn that down to 5 and 5, so I should get 25 rooms in total. 5 columns of 5 rows. Or 5 columns of 5. Yeah, because 5 times 5 is 25. Map generation from instantiating tiles and options setting of map. The map is functional. Okay, so yeah. The sizes are controllable over here. Map size adjustable by designers, and at least 3 source tiles exist. Okay, so that's this part right here. AI players spawn not present at level load. Since this is level 1, this is the level that it actually goes to, you can see that there are no objects on level 1. So, yes, it is required to spawn them. This is abundantly apparent when you play the game. Because, look, now I'll go back to here and it still saves the player count, even though I actually ended the play mode for it. So as you can see here, we are now in level 1, and all the stuff is created. And I'll go ahead and pick up the power up just because. There we go. So you can see that the power up pickups work. Okay, so yeah, we did that. We did that. Oh. You know what? Let's go do that again so you can see it respawn. It's a bit harder to tell with the Battlestar Galactica style camera that I'm using. Do. Okay. So now I'm going to back up and let the camera readjust, and then you can see. Yep. See it responds after a fixed amount of time. And I did the bob and weave because that to me just like, boom, boom, this is a power up. Look, it's calling attention to itself. Okay, so you can see the power ups respawn after a set time. I'll have to show this one in code because I didn't implement any kind of GUI to show the activation of a given power up. I'll have to also show this one in the code. I'll show that one in code. I've already shown this one. I've already shown this one. Oh, I'll show this one real quick. And I'll talk about the game sounds while I'm doing it. Okay, so still single player mode. I'm gonna go ahead and use my old fallbacks of O and L. So I hit L, I up my score, and then hit O, and I decrement the lives. So there it is, going beneath 0 and getting the game over. So then here's the game over screen. Here's the high score that you had. Then you hit the try again button, and when you go to high score of all time, it didn't save it, but that's fine because it did actually push it to the options. It just didn't pull it from the options. Okay, but yeah. Manager exist, game sounds. Okay, so I showed the game over. The game sounds play, so you are currently hearing the music for the game. Well, play the game again. You can hear the music for the game. There's the coin chink chink for the button press. And the other chinks in the background are the bullets being fired. That's currently the enemies turned and aiming at the ship and firing at it. See? Yep, there we go. There's an enemy that's off screen currently shooting at my ship. I think I'll just sit right here and let it hit me. Okay. So there's the sounds for it firing. Alright. So then with there's the game sounds. I'll cover the game manager right now. So here's the game manager. And the game manager is pretty straightforward. Here's player ship 1. This is the ship for when there's 1 player. This is the ship for when there's 2 players. So rather than doing the rect, new rect, I actually just have different ships. And the main reason I went with this method was so that I could actually load different sprites for the ships without causing an issue. And yeah, that's pretty straightforward too. So like with player 1, the only real difference between player 1 and player 2 right now, because I haven't done anything special with them, is the viewport rect, and that's it. One has one type of viewport rect, the other has the other type of viewport rect. So it's nothing really too complex. But now I'm going to go ahead and go back to the game manager here, and go over all the topics that it wants. So here's the map seed, the player health, the player invulnerability time, the kamikaze health. This is just variously the health for the various different types of the enemy. The player fire rate, the player forward speed, backward speed, rotate speed, enemy speed, rotate speed. Avoid block time, this is how long the AI will attempt to avoid an obstacle in their path. This is the number of hostiles the map will spawn. This is the was really used in implementation. Here's the speed of the bullet that's being used, and here's the duration, how long the bullet goes before it just self-detonates. Here's the respawn timer for the power-ups. Here's how much faster picking up a speed power-up makes you go. Here's how much health picking up an up health modifier gets you. Here's how much more health the up max health modifier gets you. There's the fire rate up modifier, the up score bonus. The power up speed modifier, the main important thing with the power up speed modifier is it also can be applied as a debuff. There are existing implements for it to be used as a debuff. And you could see all of the other various implementations in the game manager here for it, including the collision layer for the raycasting. Alright, so lastly we're going to go through, you can see in the console here, despite having just run the game, that there's no errors. But I'm going to go ahead and go through some of the comments for the code, stuff that I really liked while I was working on it. So we have our room generator right here. So let's go pop into Visual Studios and take a peek at that. So this is one of the more unique aspects of this particular project, because the scene management and everything else has been a part of the project, and I dealt with that during the first instance of the class, or during the first level of the game programming class. So since I pretty much use a lot of the same stuff except with actual working code this go around, I'm just going ahead and gonna skip over the most of that. I use case statements and switch statements a lot instead of relying largely on if statements, because with the switch statements it seems to work a bit faster and they're easier to expand because I just have to add a new case. I don't have to worry about counter-violating existing if conditions, if-else conditions. I don't have to worry about something being nested. So stylistically, it's just a lot visually cleaner, and it's easier to scale up. So I end up using switch statements for my statements in my game a lot more often than I use if statements when it comes to making a series of choices, or doing an action for a choice when there's more than just like a yes or no choice. This is actually what I use to generate the room. This is what I use to choose the room. So what it does is it just goes down through here and it chooses which room it's going to implement, and then it instantiates that inside of the array. And then this was a handy bit of code. This was a really handy bit of code because in order to refill all the rooms, you have to clear them of their assigned pointer object, because these rooms is actually a game object array, and it's what's holding the actual game objects themselves prior to being implemented in the game. And in order to blank it out for a new run so it doesn't throw errors, you actually have to clear the list, and then you have to trim the excess, so that wipes out all of the pointers in it, so it doesn't throw you any more errors, which is very, very, very handy, because otherwise you have tons of problems. Namely, and the only reason I really knew like off the bat what was wrong with it, it's like, oh, it's pointing at something that's not there, and I was able to just like look at it in the inspector and be like, oh, okay, well, that's the problem. Sound Manager is kind of unique for this project, so I'm gonna cover it just because due to the fact that there is the occasion where we're using more than one camera. That's something new to this, and that's because of split screen, or I can say it's because of split screen, but actually it's due to the fact that we're doing a multiplayer game, because there's single player games where you'd end up using multiple cameras, but due to the way that we have to handle the listener, it makes sense to have like a global sound manager. And the neat part about this one is that my global sound manager is actually global, because I dealt with the audio fall off by very clearly just, jacking it straight up to the top so that it's audible everywhere in the map. And that just has to deal with tweaking the 3D fall off for it. So that has to do with the way things echo or sound when they occur within a 3D environment. And I just said, okay, you're not going to degrade over distance. So the sound that you hear in the game is just global. The shots are global, the music's global. Everything's pretty much global. I think I'll cover the game manager as well. Just because the game manager is like the central hub of most of it. And I said I was going to show you the player spawn. So when we initially start the game, we have to instantiate the player. And the player gets instantiated right there. So all that really does is this player equals instantiated player ship, player start, quantorian dot identity, which means it doesn't have any kind of rotation to it. You have the player ship, you have the player start. That's pretty much the start and end of it. And then you have get hostile spawn, because if it detects that the enemies are null, it does the get hostile spawn. And what get hostile spawn does is it finds all the locations that you can get that you have the player spawner at. It creates a list of them. It declares that game object hostile spawn is known. And new bogey is actually going to be the instance of our enemy ship. And what that does is once it instantiates as a new bogey, it goes ahead and pushes that into an existence and makes it, and then it places it, and then it adds it to the list right here. So these enemies is actually going to be the list of enemy ships in the map. Very straightforward. It also does this when it first generates the map, because you see, it calls this map maker to generate the map. This map dot create map. Create map is actually the function inside of map maker here, which kicks right there. And that's what actually procedurally generates the map. So they should be created, but just in case they aren't, or if you destroy them all as it's running through the update, because this is in the update loop, and this is, again, another switch. The switch this time is determined by what scene you're on. So if you're on the start screen, and it's telling you that the game has not started, because if this is true, then it skips over this. But if game started is actually false, it inverts it, so it would be true, so it goes through this. So then it says game started to equal true, it sends map generated equals to false, it sends player score to 0, and it does the whole play intro music, which just starts up the music track. It's not a super hard thing, because, I mean, the music, what audio is being played is actually controlled in Game Inspector. So when it just says intro music, level 1 music, game over music, it actually pushes that to the audio source by multiplying the music volume against the master volume in order to determine what the actual float would be, resulting from those two hitting one another. So if master volume was 1, but music volume was like 0.025, it would be 0.025. But if master volume was 0.5 and music volume was 0.5, it would be 0.25. So it would be 1/25 of the maximum. It would be 1/4 of the maximum volume that the music could play, because the master volume would be down to 50 and the music volume would be down to 50 as well. So the master volume controls the overall volume of the game, and the music volume is just the volume for the music. That's the unique feature for mine. It's really not that hard to implement into the game. It's just the implementation is geometric. So every time you add an additional control scheme, you also have to add an additional requisite supporting structure for it. Because you can't, well, you can just make buttons that do a pre-assigned, pre-understood task. The number of things you have to do to accomplish that task can grow significantly. But that's dynamic design theory. I didn't want to go off on that tangent because I could speak for hours on it. one of the other ones that I want to cover before I go back that I didn't cover in one of my previous that I did not cover in one of my previous ones. Although that's pretty much most of it. I'll just go into here. So for the structure and the organization, you can actually see that the player ship up here is an empty that holds the camera and the ship sprite itself. And I had to make this adjustment because we had the issue of, well, I had the issue of when the camera was a direct child of ship 8, the problem that we had, well, that I had with that was the fact because the ship itself was scaled down. Whenever you would rotate the camera and then attempt to move the ship, it would glitch out the graphics because you're attempting to move a camera at that point, which was effectively scaled down. It took me several hours and talking to the professor to find this out, but yeah, don't attach a camera to a scaled down object. Don't resize an object with a camera on it. Redo the hierarchy of your objects in order to ensure that your camera does not scale down, even if you have to scale down whatever the physical graphic you're looking at. This was a very informative incident for me, and it went very far to show me how gnarly the programming problems can be, or design problems can be, especially when you're dealing with calculations of scaled down cameras, because suddenly the frustum becomes completely out of whack, and it's just, wow. But yeah, so let's go into some of the scripts. Did say I was going to cover the AI and the power-ups. The AI and the power-ups. Okay, so I'll just go straight into the scripts here. Take this back to that regular screen. So for the power-ups, the whole permanent, non-permanent thing, that's actually going to be controlled within here. So we have power-up for each power-up, for each expired power-up and power-up, remove. And then this is on the pickup. So public void, add power-up, power-up, power-up. If power-up is not permanent, so if the permanent property is not true, then it goes ahead and adds it to the power-up list. But if it is true, then it's a one-time pickup only. So for the score, a health package pickup, or well, pretty much just those two. So if it picks up a score power-up, or if it picks up a Band-Aid power-up, that's permanent. There's no reason to remove either of those two, because once it goes to the score, it's gone to the score. You don't decrement the score when the power-up expires. That makes no sense. I deliberately sought to choose power-ups which would make sense for permanent duration and temporary duration. So speed boost and like overshield for the ship makes sense that they expire. The one unique thing that I had for the health was that when you get the supercharge health, if at the end of the time your health would be reduced by what its maximum value is, but your current value for your health doesn't reduce if it's already less than the new maximum health. So if you had a boost which was taking you from having 6 health to having 8 health, at the end of the time, if you have 6 health, it doesn't kick you down to 4 when the overhealth expires. because that didn't make much sense for me. Because if you have the overshield on and you took 2 hits, and then the overshield expired, it would put you down at 4. With the way that I was going for the health boost, that didn't make sense to me because it felt like I should be expanding what your maximum possible health was, and at the same time adding that new difference of health, rather than just absolutely, okay, so this is a temporary booster. When it runs out, poof. If you have 6 health, it boosted you to 8, but then you took 7 hits. If it expired, it would kill you. So that didn't make sense to me. Because the way that I was dealing, that would make sense if you're doing like a rage power up, but with the way that I was doing the power up with like the health overboost, it doesn't make sense to me that when the health overboost expires that the player can die from that. If it was like a berserker or like a rage power up where it gave you like false life over how much life you had, which would effectively allow you to keep blood raging even if you'd taken enough damage to kill you, and that when you came out of the rage you'd die. That's very D&D-esque. But for this one I just wanted it to be a health overcharge, so it made more sense for me to gear the power up in that fashion. So I'll go to the power up script here. And you can actually see I'm using the enumerators again in order to determine which power up does what. And this just basically sets the flags once it's declared. So you choose the enumerator when you attach the script to the power up, and then it just makes the sound when it's run over. It's actually not that hard. Yeah. Here's it playing the audio source when you run over it. But other than that, it's very, very straightforward. Because I mean, if it's a permanent, it doesn't need power. It doesn't need iteration. So you see that line of code missing from these 2, or these 3. Cash money, and it defaults to being a true, and it defaults it to being a score, so that it doesn't have any breakdown issues if for whatever reason it ends up without an enumeration. Which I mean, it never should, because when they're spawning from prefab, they already have an enumeration chosen for them. Okay. Everything else is very straightforward. I mean, I'll go ahead and show the AI because that's part of the choices that we have. So here's Hostile Gunner. That just tells it to shoot at the player. Here's Suicide Runner. What this does is it enters into, when the player enters into hearing, which I know works because it works up here, the AI will attempt to kamikaze into the player ship. So here's Hostile Gunner, that's my first one. Here's Suicide Runner. That one's just the avoidance stage, so if it's just like trying to chase the player, but it can't reach the player because there's something in the way, then he goes ahead and kicks a do avoidance from the do chase. So if it tries to chase the player but can't chase the player, it sets the avoidance stage. The avoidance stage does the do avoidance function instead of going down in here to do the here player do chase. And if like the player manages to duck behind an obstacle and the AI is chasing him, if they get done with the do avoidance and they can't hear the player anymore, obviously it doesn't execute the do chase anymore. Dive Bomber is like, it's kind of like the Suicide Runner, although it checks the Shell Dive Bomb, and Shell Dive Bomb just checks to see is the player far enough away that I can start my bombing run. And if the player is far enough away that they can start the bombing run, then they go ahead and do that. But if the player's too close, it actually switches into the begin fleeing. So I'll go down here to the do bombing run. do avoidance. It's pretty much just do avoidance. So it just sets the target away from it. And here's the can move for it. Here's the everybody for themselves. Here's the waypoint following ones. So with the patrol method, we have the go through it and stop. We have the loop, go through it, and keep going through it. We have the ping pong, which means go through it this way, then come back this way. And we have the default. Once again, default. If it doesn't have a patrol method, it just says patrol method stop. All that does is follow waypoints. Here, player, this is actually doing the check for the hearing distance. Follow waypoints, chase player. Chase player just uses the rotate towards and the current magnitude, so the square difference between the two. So if they're already looking at the player, they continue turning towards the player. If they're not looking at the player, they turn towards the player. If they are already looking towards the player, they go ahead and shoot at it or begin to chase it and shoot at it. So they're attempting to follow the player before they shoot. So if the player like zigs out of their line of sight, they'll actually rotate towards the player before they continue chasing, which makes it nice. Here's the fleeing one. All it does is it gets a vector that is away from the player, and it keeps them in this state until they're no longer near enough to the player that it keeps them in this state until they are no longer near enough to the player that it says, okay, they're within your threat distance, you need to run. It moves them away until they're far enough away from the player that that state no longer triggers. My brain. Alright, but yeah, that's the AI state. Okay, so that'll do it for me.